Welcome to my YouTube channel. Today we will be discussing about angle of loll and corrective actions. So let's discuss about the topic. Angle of loll. When a vessel has negative metacentric height, then it is in unstable equilibrium. So any external force applied to this vessel will cause it to start heeling. So this is the condition. When a vessel is in negative metacentric height, that is, it is in unstable equilibrium. So if we apply any external force, then the vessel, there is a chance of it to start heeling. So this is the condition of negative equilibrium. So that's shown in the figure. As it heals, the moment of inertia of vessel's water plane, that is, plane intersecting the hull at its water surface. So moment of inertia of vessel's water plane increases, and this will increase the vessel's BM and distance between the center of buoyancy and metacenter. So when this water plane in moment of inertia of water plane increases, so the vessel's BM also, buoyancy, center of buoyancy to the metacenter will also get increased. When the moment of inertia of vessel's water plane increases, then vessel's buoyancy to metacenter, that will also increase. Since there will be relatively little change in the distance from the keel to center of buoyancy of vessel, and Km, distance from keel to metacenter of the vessel, that will also increase. So if there is little change in Kb, that means distance from keel to center of buoyancy of vessel increase, then Km from keel to metacenter also increase. That means from keel to buoyancy increases, automatically it is directly proportional. Then keel to metacenter buoyancy will also increases. So at some angle, for example 10 degree, if Km will increase, that means from keel to metacenter, if increase equal to that of kg, that means from keel to center of gravity, then Gm, metacentric height of vessel, will be equal to 0. So the condition is at some angle that from keel to metacenter will increase equal to the distance from keel to center of gravity. Thus make metacentric height will be equal to 0. When this occurs, vessel go to neutral equilibrium. At angle of heel, at this position happen means this is known as angle of heel. So what we are discussing is at some angle of heel. So example 10 degree. This Km, that means from distance from keel to center of gravity and distance from keel to metacenter. When this became almost equal, then metacentric height of vessel will be equal to 0. Then we can say vessel will be in neutral equilibrium, and when an angle of heel happen at this position, then we can say this process is known as angle of loll. This is what happened in neutral position. When the angle of heel happen, it will be known as angle of loll. Normally at an angle of loll, vessel oscillates about its angle and return to her angle of loll position. Normally it will come to the upright position and get stable. However, even though vessel appears stable at this angle, this condition is dangerous and must be corrected. Yes, this is kind of neutral equilibrium, because the chance of ship getting upright to get stabilized position is there, but this position appears to be stable, but this condition of angle is dangerous, it must be corrected. An unstable ship with this angle of loll could cause the ship to capsize. So if something happens, the chance of getting ship to capsize is much more, because it's only if the angle is increased much more, then chance of ship getting capsize is very high. So what are the corrective actions? Angle of loll can be controlled or corrected by lowering center of gravity, not by moving loads transversely. So what we can do is, first we can reduce the center of gravity, so that not by moving loads transversely, then we have to press up all slack tanks and lower weight as possible. We have to press all the slack tanks and we have to lower the weight. First that I mentioned is we have to lower center of gravity, lower weight as possible. Then if ship is discharging cargo, discharge from the high side, we have to, which helps the lower vessel center to lower the vessel center of gravity. Yes, if you are discharging cargo, we have to discharge from the high side, so that we can decrease our center of gravity, and we have to run self watering ballast tank water on the low side, and we have to fill the ballast tank water on the low side. we have to fill the self water in the ballast water tank on the low side, and after this tank is full, run its counterpart on the high side. Repeat this action with other tanks until ship becomes stable. Here what we are doing is correcting we have to reduce the center of gravity, reduce the weight. That means if you are discharging the cargo, discharge from the high side so that center of gravity will get lowered, and we have to run self water in the ballast tank, water on the low side. After this low side one tank is filled, run to the counterpart on the high side and repeat this action until the ship becomes stable. This will be the corrective action during angle of load. Thank you.